All right, good evening, everybody.
Hello.
Hello?
Hi there. Hello.
Yeah, we hear you.
All right, good deal.
Yeah.
All right, so let's get started with week 2. One thing just want everybody to know is you can definitely chat questions in whenever you want to. I'll send a quick chat out here for everybody. You should be able to see chat windows. So if you have any questions as we go along, you just want to type them up, that's great. You're also more than welcome to just ask directly, but sometimes people are a little more comfortable chatting questions in, and then sometimes it can be a little easier to kind of pick the spot when I respond to stuff too. So definitely feel free to chat any questions that you have, and I'll do my best to answer them. So first thing I wanted to make everybody aware of this week is I've gotten moved ahead a little bit here with getting some of the assignment stuff posted to Blackboard, and you have to forgive me this semester. You'll be getting your stuff kind of just in time with a lot of this because it's first time going through the course, and I'm going to be using a little bit different software than some of the stuff I've used in the past. So I've got to kind of get everything translated over into the software that we're using. So first thing I want you to know is assignment 1, install software. I've put the screenshots up that show really what you need to deliver for this first assignment. And if you download this thing, give me just a second, I'll pull this thing off the screen. If you download this thing, you'll see that I've got a couple of just really 2 screenshots you have to be concerned about producing. The main point of this assignment is just making sure that you have the tools available that we're going to be using in some of the later assignments. So I'm going to go through and show you guys a little bit about this tonight to make sure that everybody's comfortable with what you need to do. This is really a softball assignment. I mean, you got to install a couple pieces of a software and essentially prove that you did it. So it'll be easy 50 points for everybody first thing up here. So let me pull that off here. The other thing that is up here is the assignment's free, and really you guys could start working on this whenever you wanted to. I put up all the screenshots, and I'll show you a little bit about Swirl, the program that we're going to be using to kind of get ourselves familiar with R and RStudio, so that we're prepared when we get to Chapter 5 to start using R. So the textbook, I think, talks about Enterprise Miner or some software like that. And I think that's what they show in some of the appendixes. We're going to focus on working through the data sets and the examples from the textbook using R. We should be able to kind of translate everything that's in the textbook into an R format. And the reason that I chose R, and I'm just going to mute everybody so we don't pick up background noise. If you want to unmute, just let me know, and I'll unmute you. The reason that I chose R is it's really becoming, from a data mining perspective and a statistical perspective, R is really becoming a very popular software package. And one of the things that's great about R is it's free, it's open source. There are some organizations like Oracle and others that are putting out their own versions of R kind of built on top of the open source stuff. But the beauty part of it, it's free. Anybody can use it for whatever they want to. And people are out there producing all sorts of packages for R all the time. We'll take a look at some of those tonight too, which makes it a really, really handy program for doing stuff like data mining. Now, the downside to R that we're probably going to experience just a little bit of is the learning curve's a little steep. So this assignment 3 is really going to be focused on just getting you guys comfortable with the basics of R. And you can see, hey, geez, Arthur, you got 15 different things here in one assignment. Yeah, it's all pretty easy though. And I don't anticipate that this will take you, you know, maybe more than a couple of hours. You know, maybe as much as 3 or 4 hours, but it's fairly simple, and it's really just working through getting comfortable with our interface and understanding kind of the basics of how R works. Ultimately, we'll be using R to do the data mining techniques described in chapters 5 and onward. My objective isn't to make you guys suffer too much from an R perspective. I'll feed you a lot of the stuff that you need in order to do the things that we need to do inside of R. The purpose of this course isn't either to make you you know, build data warehouses or you know, from scratch without you know, sort of any help, or to make you you know, try and figure out how to do these sort of complex things that we're learning without any help either. The objective really is, I'm a learn by do kind of person, and I find that most people are. So we're going to take the concepts that are described about data warehousing and data mining, and we're actually going to apply them on some data sets that we have. From a data warehousing perspective, we're going to explore one of the things you might have come across in data mining. We're going to take a look at, hey, we'd like to pull some data off of social media and be able to do something with that data. We're going to take a look at, okay, you know, what are some of the challenges that are involved with pulling some of these sort of semi-structured data sets off of the APIs provided by social media, and then, you know, how do we make that data useful, right? Because it doesn't really come out of these systems in a way that's readily usable for the type of things we want to do. So we're going to talk about some techniques and just kind of suffer through a little bit of how we might transform data like that into something that's a little bit more useful. And then the other thing that I want to kind of get across to you guys is I want you to be at least comfortable with using SQL against relational databases. And I'm assuming a lot of folks have probably done that at this point, but one of the most powerful languages that you will ever use for data analysis is SQL. And although I don't tend to make you an expert on that either in this course, I want you to be at least familiar with it a little bit, to use it a little bit, and I really want to get you know, the point across that it is worth your time to learn. So really, you know, during the semester, I want you guys to pick up on the basics of SQL, recognize that databases are really good at organizing and manipulating data, especially when we're using data warehouses. And then we're going to eventually see how we can integrate our usage of the relational database and SQL with tools like RStudio and use those things together. Data mining one of the things that people have to understand when they start digging into this type of stuff is there isn't one tool that you're going to use to do data mining, right? Because as we take a look tonight at the CRISP-DM process, we're going to discover that there's a lot of stages that go into data mining, and there's a number of different tasks that are best accomplished by different tools. And, you know, if you're dreaming of becoming a data scientist and making tons of money and making all the people around you feel stupid, then you're going to definitely need to become familiar with a number of different tool sets in order to sort of do your job, right? Or if you're just going to be a data analyst and kind of dip your toe in data mining and data science, there's a number of tools that you might need to use. You know, one of which may be R. Python is another big data science language and data mining language. But SQL is 100% guaranteed going to be a part of your life, and you will never regret dedicating some time to learning how to use it. Other things, there's also a number of really powerful commercial products for doing a lot of the stuff that we're going to do and kind of making it easier. But those come at a high cost, and especially for folks who are trying to get into you know, doing data mining and really kind of discovering whether or not this is something they're really interested in. Open source tools like R are extremely handy because they don't require a huge upfront investment in order to get started. So, okay, assignment 1, assignment 3, the screenshots are there. You can work on these assignments at your leisure. I will get the screenshots and other things that you need to do assignment 2 up later this week. And then next week, we will really dive into the tasks around doing what we need to do in assignment 2, and we'll really dig into data warehousing and sort of the meat and potatoes of how you actually go about technically implementing one. We're going to build a small kind of simple data warehouse that hopefully hits on all the concepts behind data warehousing, and then ultimately, like I said, we'll use that in some future assignments. From a reading perspective, this last week really was just the first 3 chapters of the data mining book. The great part about this textbook is it's actually not very long at all. I think it's only a couple hundred pages. So, you know, 3 chapters sounds like a lot, but I think I might have asked you to read like, you know, 45 pages, and there's a bunch of appendix and assignment stuff in there that you don't have to go through. So really not too much reading. Reading for this week, really digging into the Kimball stuff that's going to give us the foundation we need to understand the data warehousing. There's kind of a lot of meat here. You know, this is maybe a little bit more reading, but still not too hard. And I don't expect you guys to like read this, and I'm not going to quiz you on it. What I want you to do is understand the concepts behind why data warehousing is necessary, and then the sort of fundamental concepts behind how you go about designing data warehouses. Now, data warehousing is not new technology, and frankly, neither is really data mining, right? All of these things are probably 30, 40 years old in the sense of the methodologies, you know, have long been established. Ralph Kimball and the Kimball group were really instrumental in codifying how it is you go about building data warehouses. And they really kind of got it right a long time ago, and their the techniques and processes that they designed and codified for creating data warehouses have really withstood the test of time. And even if you're not going to be sort of involved in data warehousing, if you're going to be doing any type of data analysis work or even report building work or data science work, I think it is highly, highly useful to understand how data warehousing works, because typically, even if you won't be using typical business intelligence systems or reporting systems when you're doing data mining, you will often be a consumer of data warehouses or data marts. So understanding how they're designed, why they're designed the way they are, and really how to access the data inside of them is well worth your investment in time. So, okay, there's my spiel on why data warehouses are so wonderful, and we'll talk about that some more. But first, why don't we dig into what you need in order to complete your first assignment. So what you're going to need to do, and let me just pull up my virtual machine here. Drag this over here. This computer is still okay. All right, so what you're going to need to do, and you can see I've just got a little kind of development virtual machine here, and there's all sorts of trash all over it, but I put a video out on YouTube, and it's linked on our Blackboard site that kind of shows you what you need to do to install R and RStudio. And if you have correctly installed RStudio, when you open it up, it should recognize the R version that you have installed on your machine, and hopefully this should go pretty smooth. It's really pretty simple process, but if you're having a problem for any reason, please feel free to reach out to me via Skype. I will be more than happy to help you with any problem that you're having, and we can figure it out. If you're a Mac user, I'm not one, but I've been fairly successful in the past in helping people work through problems on Macs as well, although most of the time those seem to be a little smoother than some of the Windows boxes. So hopefully it goes well for you, but if not, reach out. We'll figure out what your problem is. So, okay, what I'm going to need you to do, or what I'm going to want you to do when you get RStudio up to kind of prove that everything is in great working order here, is I'm just going to want you to populate a couple of variables. So I've got the text for how to populate these variables in the assignment 1 screenshots document. And really, if we come over here and you just paste these into your console here and hit enter, you should see that these two variables are populated. Now you can see I've got a bunch of other garbage down here. Don't worry about that as far as these functions for the time being. All I need to see from you guys is this my computer, my version. And what I want to see is that you have the correct version of R installed here. And then the other thing is this is just going to show that you've actually got it on, your machine, right? So, hey, prove to me that you installed this thing on whatever computer you're going to be using. And that's about all you need to do. Now, some of the getting familiar with RStudio, don't feel like you have to wait. You can start playing with this thing as soon as you want to. If you want, if you take a look at the setup here, you say, oh, when you first log in, you may not have a setup that looks like this. It might not have these 4 panels. If you need to configure this to kind of get it the way you want it, if you look under View and Panes, you'll see that there's actually this pane layout option that will let you determine what goes in each pane. And we'll be kind of discussing this more in the future, but if you're just interested in getting moving with this thing, the two most important things are this console and the source. And then you're going to need to have your environment in this lower pane in order to show the results of populating those variables. So if you're able to get R and RStudio installed, then just drop the two variable definitions I've given you into the console. If you have your environment pane up here on the wherever you choose to put it, but at the bottom left-hand corner, you'll see those values for those, and you'll have what you need to do the assignment. And again, if you're having any problems with any of this, you're more than welcome to reach out to me. Now, the other thing that you're going to need really to get to assignment 3, and I'll just tell you about it now in case you want to get a jump on it, is you're going to want to install what's called a package with inside of R here, right? So out there on the interweb, lots of friendly people are always creating things for R that you can download and install, and it's pretty auto-magical. I'm going to show you a couple of commands here. We're going to be interested in installing this package called Swirl, which will allow you to do all the exercises that you need to do for assignment 3. So first thing I'm going to do here, I'm just going to remove it from this machine so we get rid of it so we can reinstall it. And then we'll see here that I'm going to say, hey, go ahead and install packages Swirl, and this thing will go out to either go out, you can see here, to the CRAN site and pull this down and install it for you. And then the only thing you have to do in order to be able to use it at that point is just using the library command. Say, hey, I want you to load this Swirl library up. And you can see that Swirl will begin kind of talking to you immediately at this point, right? So it tells you here, hey, just type Swirl and we can get going. And then it says, hey, what do you want to call? I'll be boring, just put my name in here, and then it'll walk you through kind of getting started with the application. And then the whole point of Swirl is it has a bunch of teaching modules on it that can show you, various things to do inside of R. So if I hit continue there, it's just going to tell me a little bit more about, hey, how to get started. And then if I just kind of follow along here, it'll give me the basics of how to interact with Swirl. If I want to pause and screw around, I can use this play command. And then when I want to come back, I can use this next command. And you'll learn all this stuff as you go through the lessons. But after that, you can see that it will give you, hey, here's all of these courses that I can go out and fetch for you. And what we're really interested in is the first one, the R programming, the basics of programming in R. This one, it will go out there and fetch that for me. And then you can see here, I can choose the courses I want to do, R programming, and then you'll see here that these 15 things tie exactly to what I've got in the assignment 3. And then really, at this point, you're just going to walk through these one at a time. Be sure to follow along in the screenshot document and collect up the information you need to collect as you go along. And I really just want some screenshots to prove that you went through this and have, worked through this basics of R programming. Again, this should be another kind of softball assignment for you because all you need to do is follow along with Swirl, take some pictures that I've got in the document, submit them for the assignment, and boom, you get credit for it. So I'm not going to worry about selecting any of these right now. I'm just going to jump out of this menu, and you can see there, I think if I ultimately want to get out of this thing, I can just type by, I think it says, right? The other thing you can do is you can go out here and look at the Swirl course repository. If you do this and you're, saying, hey, I want to do some more of this, you can see out here on GitHub that there are a number of different courses that people have put together, and you can really go as far as you want to with that. If you're really nuts, you can even contribute to creating courses. And then you can see here that they reference this swirlstats.com site, and this is really just a little site out there, for Swirl. They've got some help about how to install R and getting R Studio and all that type of stuff. So if you're looking for the spot where the resources are for figuring out what to do with Swirl, then you can come out here and they should tell you anything you need to know. And then they've got blog and frequently asked questions and that type of stuff. So it should be able to get you everything that you need, and then obviously I'm always around to help you as well. So that's really the gist of what we need to talk about with RStudio tonight. But we'll be diving back into this extensively throughout the semester. So you're going to want to get comfortable with this thing, and you're probably going to hate me if you've never touched R before and you're maybe not particularly inclined towards having ever programmed anything. Then this might hurt a little, but you'll get the hang of it. And once you get comfortable with R, it's remarkably powerful and also not that hard to use. It's just a matter of getting used to syntax and how you do different things. But I'm confident you guys will get the hang of it because I was able to figure it out. I'm not that smart, so I'm confident anybody can figure it out. All right, so now the other thing that we need to do is you need to install SQL Developer. SQL Developer is freely available from Oracle, and if you were to go to the interweb here, let's just look this up. Oracle SQL Developer. You come out here and you'll see, hey, this is a freely available tool from Oracle for accessing their stuff, but anybody can use it. If you've not ever signed up for an Oracle account before, you'll need to get their solutions. Now, one thing about Oracle software, SQL Developer is free, so you don't have to worry about it. There's nothing to really be concerned about. But if you're familiar with Oracle, they sell databases and all sorts of software. A lot of it around ERP systems for managing your business, and their software isn't cheap by any stretch of the imagination. But one of the nice things that they do, if you're a student or a developer trying to figure out how to use your stuff, you can sign up for a free Oracle account. They won't harass you or sell your stuff off. They're actually pretty good about that. And then almost everything that they make, for on-site computing, you can go out and download for free and use to teach yourself how to use it. So in any case, you'll need to sign up for an Oracle account. I'll let you figure that out. It's not rocket science. And then you can come out and download SQL Developer. They've got an early adopter version out here, but what you're most likely going to want is the probably Windows 64-bit with sort of everything included. Or if you're a Mac user, then you'll want to download the Mac thing. And they have notes on how to install that, so I'll leave it to you guys to kind of figure that out. It's, download a program and click install essentially. So it's not rocket science. Now, once you have SQL Developer installed, you're going to want to connect it to a database that we have out there. So I have gone through and created an account for everybody, I believe, using the user IDs that I see on Blackboard. The only difference between maybe the user IDs on Blackboard and for this Oracle database is I've got everything in uppercase here. So just be aware of that. So what do you do if you're going to connect, right? So you come out to SQL Developer, you open it up, and you're probably going to have nothing. You're not going to have anything in this connection section. What you're going to do is just click the plus sign, and you'll get a panel that shows, you know, the information or asking you to put some information in for a connection. Now, I'm not going to go through typing this, but you'll just see something that looks like this. You won't have all this 5 billion connections over here like I have. But you'll see here that I've got this test user, and I've touched a couple other people's users just to make sure I could connect with them here. I've got a couple of test users here, and if I click on this one, you'll see I've got this A-Date test user. And this user is set up exactly the same way that yours are, all of your other users are. So this should be the exact same thing that you guys go through. And in the document that I have on Blackboard, I've got let me pull this up. I've got the connection parameters down below the screenshot here, right? So I'll show you what you need to do. You can name your connection whatever you want to name it. You'll put your username in here, and everybody's password is change me, all caps, for when you log in. And then you can see for the host, we've got this IP address. That'll be the same as you see in the picture here. You have the port, it'll be the same, and then this service name, you'll want to type that in is exactly as you see it. Once you have put all this connection information in, you'll want to change your password. And I've got a little screenshot for that here too, but I'll show you guys how to do it as well. Make sure there's no chats. Okay, so you've got your IP address in for the host, you've got your port, you've got your service name, your connection type is basic, and your role is default. And at this point, you should be able to click this test button, and if the database hasn't face planted or I haven't otherwise taken it offline, you should see a status of success over here. And at that point, you can just click the connect button, and you should see if you give it just a second, you'll end up seeing just a blank SQL worksheet, which you can then put some SQL in to complete this assignment. So, okay, give this just a second. It should pop up a blank sheet for us. There we go. So you'll see something looks just like this, and then you should have, if you didn't save your connection over here, and you should have your connection saved, and then you should never have to enter any of that credential stuff again. You can just come here and right click and connect next time you need to access this. So the very first thing you're going to want to do is reset your password. Click this reset password. You'll put change me in here, and then you'll put a new password in that isn't change me, right? and it isn't password 123. So put that in here, click OK, and it'll change your password for you. In order to get credit for assignment 1, do be aware that you need to change your password. And I'm going to come out here, and I'm actually going to look, right? There's a table that I can look at that shows me the last time that your password is changed. And so I'm going to expect everybody's password to have changed after, today, or at least after the time that I created everybody's users. Then I'll check that as a part of assignment 1. So get full credit. Just make sure you change your password and everything is hunky-dory. So then you're just going to want to put this little piece of SQL in here. Again, that is the whole purpose of this is just to prove to me that you actually did what you're supposed to do. So this is in the document as well. Drop this into your SQL worksheet. Click this little green triangle. If you're not connected, it'll ask you to connect, and then you should get results that look just like this, right? So what is this telling me? This shows me the private IP address of the database server, so everybody should get the same number here. The user, so I would expect to see your username here, and then obviously this is the service name that we're connected to, so this will be the same for everybody, and then this shows that we're connected with SQL Developer. You take a picture of this, put it in a Word document with the screenshot that you needed from R, and boom, you've completed assignment 1, and you're in good shape there, right? So that should be everything for assignment 1. This should be real easy. I would expect it to take you, maybe 30 minutes on the outside. Including the time it takes to download and install everything. If you are having any problems, definitely reach out. Do be aware that the week, there's going to be a couple of weeks that I'll be traveling for work, so my availability may be a little spotty. I'll be sure to put an announcement out there that tells everybody, when I'll be available or when I'll be traveling. Really, I'll be available, should be available at night during those weeks. I'll be on the West Coast, so I'll be a couple hours behind you. So if you're working on something at like 8 or 9 o'clock, that'll probably be about time I'm getting back to my hotel room and be able to help you out. But if you need help, shoot me a message on Skype. I will see it when I log on to my computer, and you can ask me a question directly. I can try and answer it, via chatting on Skype. And then if we need to get together, I'll let you know, and we'll set up a time when we can share screens and figure out what's going on. So, all right. That gives us everything we need for assignment 1. You guys can find my contact information on the Blackboard site. You can reach out to me on Skype. Just send me a contact request. Let me know you're in the class, and then we can talk that way. All right. So now we're going to kind of start digging in a little bit to what they're talking about in the first 3 chapters of the book here. So really what they do in the first few chapters is kind of introduce you to the concepts behind data mining, and then they in chapter 3 touch on data warehousing. We'll probably focus on data warehousing a little bit more than the book does. But we won't spend tons of time there. Again, the idea is that we're going to get you familiar with how it works, let you build a data warehouse so you can understand the concepts behind it, and then we'll move on into data mining and using R there. So, what I wanted to cover this week is I really want to show you guys how to complete assignment 1. We've got that taken care of. Next week, we're going to dive into assignment 2 and what to do there. And then in the following week, we'll, I don't think there's really much to show you as far as what to do for assignment 3. You just kind of, once you get Swirl installed like we talked about, then it's just sort of follow along with the course inside of R there and produce the screenshots that you need. But we'll probably revisit it just once to make sure everybody's moving along on that. And then the rest of what I want to talk about tonight is really this CRISP DM methodology for data mining. So that stands for, what is the, I always forget the full text of the cross-industry standard process for data mining, with the clever acronym here. What that does is it really lays out an approach for data mining and begins to give us the scope behind all the kind of tasks that go into data mining. And then we're going to dive into data warehousing a little bit. We'll begin to talk about some of the concepts behind it. And then next week we'll really dig into kind of a little bit more of the concepts and then how to implement a data warehouse. And that's when we'll be using SQL Developer to design our own data warehouses based off of some Twitter information. So from the assignment 1, we talked through this. R in our studio, entirely local to your machine. There's nothing to connect to. Everything is installed on your local machine. SQL Developer is a local application of your machine, but you're connecting to a remote database that lives out in the cloud. And then the screenshots in assignment 1 and the stuff we went through in the lecture tonight should tell you what you need to do for assignment. So the CRISP-DM process lays out an iterative process for how we go about data mining, and they categorize the different kind of things you have to do in order to do data mining. And what's kind of interesting about it is, the first 3 tasks don't really have much to do with, actually using data modeling or mining techniques. The first 3 tasks are really about understanding your business problem, coming to understand the data that you need to solve the business problem, and then preparing that data to be used. And this has a lot of parallels with data warehousing. If you've ever been exposed to any reporting systems or business intelligence systems and had any familiarity with ETL or the process of populating data warehouses, this is very common thing that you need to do in that process as well. Understanding what the business problem is, your business needs are, the data that's available to you, and getting that data ready to be used by the system. And so we'll talk about this in the context of data warehousing, and then also talk about this in the context of data mining, and we'll see why data warehouses can definitely be your friend when it comes to doing data mining. So the important thing to understand about this process is that it's iterative, right? So, what that means is, often the steps down the line are feeding back in and causing us to go through the previous steps again, right? Because as we begin to understand our data and prepare it and maybe do some modeling on it, we often discover that we have to kind of go back to the beginning and iterate through these steps several times. The modeling, the techniques will often drive things that we need to do to our data, and also will often kind of expose maybe more things we need to know, which might cause us to go back to our business folks and come to understand the business process a little bit more. And then ultimately, we're going to evaluate the results of applying our data modeling techniques and really see if they have kind of solved the business problem, right? And or given us another understanding that sort of causes us to go back and go through this process again as a result of what we learned through the applying data modeling techniques to our data. So to talk about each of these sections here, the most probably one of the things people often vastly underestimate is the business understanding, right? And this, in both data mining and data warehousing, is an extraordinarily important thing to gain, and often takes a great deal of time for people to really kind of understand how a particular business operates. And, you know, if you're saying, hey, I'm just going to walk into any old business and we're going to apply data mining and solve all their problems, you're going to find out that what you first have to do is really understand how the business operates, what type of measures and attributes are important to the business, and then ultimately we have to determine, you know, what problem is it that we're trying to solve, right? What is the purpose of, you know, the applying, you know, this, you know, going through this study, applying these data modeling techniques, what problem is that we're trying to solve? And so we really have to take a business problem and formulate it into a data mining use case. So, you know, potential business problems might be, you know, what are the characteristics of our best customers, right? Or what are the typical profiles of our customers? You really, you know, trying to define a goal statement that defines what it is you're trying to know, right? Who's interested in our products? If we're, you know, one of the data sets that we'll be exploring is insurance fraud. So, you know, how do we limit losses from insurance fraud without also alienating customers, because we are you know, launching investigations into insurance claims, into valid insurance claims, right? And so, you know, we have to really come to understand what the business problem is, and then, you know, formulate our use case off of that. And typically, this is going to have a pretty broad audience of people that are going to be involved in this, right? So you're going to need somebody from the business who is sponsoring this project, who has the need and the power to kind of you know, fund this thing, because it's going to take time and resources to do this project. And then you're typically going to need the IT team who knows where the data is, understands the source systems where we're going to be getting our data from, and then obviously the analytics team. And more, you know, what is you know, what the industry is trying to drive towards, and what tool sets are trying to achieve is, you know, the IT team and the business user team and the analytics team are kind of coalescing together into you know, people maybe playing roles across all three of those areas. The big dream is that you know, more people will be able to do some of the basic skills that that are in the domain of data scientists these days, and a lot of the vendors out there are really trying to expand the marketplace for their tool sets by trying to make it easier for folks who are maybe not trained to be data scientists to begin to participate in you know, data mining activities. So then, you know, the other big thing about this stage too, is you're really identifying, okay, where is the data that we need? What type of sources do we have? how are maybe current systems addressing the business problem today or not addressing it? And then, you're really beginning to formulate a plan for how you're going to acquire the data that is needed. So, at this point, you really need the folks who are experts in the systems that contain the data or maybe encapsulate the business process that we're exploring. And then obviously, your IT folks and your analytic team folks are going to be heavily involved in this as well, because you're going to all work together to try and figure out, what data it is we need and how we're going to get it out of the systems. A lot of times your, accounting / customer relationship management / human resources systems are going to be the systems that are holding a lot of the data that you're going to be using. And so you've got to have folks that really understand those systems, especially when you're dealing with very large organizations. Those systems are really complex. So people who truly understand them are few and far between, and you're going to need to bring those people in to help you understand how it is you're going to acquire the data that you need. So next, the next part of the process, data understanding, and this is the point where you're beginning to collect and try to understand the data that you have available to you. And there's lots of different types of data that are out there. You might have demographic data, which would be concerned with age and education and that type of information. And you might have gender, race, all those type of things. And what's important to understand about that is depending on the business problem that you're trying to solve, there may be some laws or regulations against using certain types of demographic data, right? So if you think about a case like insurance fraud, some of those, some demographic data becomes, kind of, you're not allowed to necessarily consider it as part of your analysis. But then, and race would be, a perfect example there. But then, if you think about if you're doing something from a health perspective, then race might be a very important element and something you'd be expected to include in your analysis. And the point there is you have to understand the context that you're working within and be sensitive to the idea that certain data may or may not be allowable as a part of your analysis. And so it's important to be aware of that. Other type of data, sociographic, so you're talking about really the type of things that people might be interested in, hobbies, what type of entertainment they're into. And it really depends on what it is you're trying to find out on whether some of this information might be useful. But this is where stuff like Twitter and Facebook and that might come in as well if you're trying to incorporate sentiment or things that people like or get connections to certain groups and other things that may be relevant. And then ultimately you've got transactional data too. This would be the stuff that's more traditionally stored in your ERP systems, and there just might be stuff like sales or number of transactions that somebody's been involved in, right? So if Amazon is doing an analysis of what type of stuff I might want to buy they're going to be looking at, what has been my purchasing history in the past, and then, okay, what kind of demographic information do they have about me that might indicate the type of things that I'm interested in, and then also they'd be probably suggesting stuff that based on other users' behavior that might match up with mine. So being able to profile me so that they can associate with me with the behavior that other consumers have exhibited in the past is one way they might might be trying to quantify the type of things that I'd be interested in, or they might be feeding into the data mining techniques that they're using to ultimately make recommendations, that type of stuff. So the other thing to understand is there's different types of data, right? So we've got quantitative data, and that's easy, right? That's sales, that's stuff that's expressed in numeric values. So how much stuff have I bought, or how many times have I shipped, or those type of things that are additive and can be summed up and naturally exist as numeric values. And then we've got the idea of qualitative data, right? And then this is data that is typically text-based, but for data mining purposes, we're ultimately going to have to code, right? So there's the idea of nominal data, finite, non-ordered, things like gender, and then there's ordered stuff like ratings, like good, bad, or indifferent, where it's finite and it's ordered. And one of the big things from a data preparation standpoint when we're dealing with qualitative data, and we'll see this a bunch when we dig into Chapter 5, is we've got to transform these into numeric values so that we could do some of the data mining techniques on the data. And this is typically when you're digging into the more technical side here, right? Our business users are kind of out of the mix at this point, and the analytic team is probably working with the folks who have access to the data, especially if it's stored in databases, and trying to understand the data and profile the data and begin to collect it, like we talked about. So then you move into the data preparation stage, and this is really where the bulk of the work comes. In data warehousing and data mining, the one thing that is always vastly underestimated is how dirty the data actually is. So everybody thinks that their systems have clean data, and there's nothing wrong with it. And what is invariably discovered when you begin to extract data and bring data in from different sources is it often has a number of quality issues. So you have data that has a lot of missing values. If we have 5 or 6 attributes that are important to our data mining task, we might find that we have a bunch of data that is missing some attribute or another, or has some outdated value for a certain attribute. And then, we start dealing with things like orphan data, and really, you pull back the rug and you discover that data is typically a lot messier than people think it is, and you need to spend quite a bit of time cleaning it up, filtering out garbage data or orphan data that isn't actually relevant or maybe has no value. We may be aggregating a bunch of data. So if we're looking at a transactional system and we're trying to analyze sales across some customer segment or something like that, then we'll be doing some aggregation, and then we'll be dealing with both missing values, and a lot of times you'll come across duplicate values. It's a very typical situation in ERP systems where you'll have one customer that might be identified by 5, 10, 15 different names. It might be UNO on one transaction, University of Nebraska on the next transaction, UN of Omaha or something on another transaction. You can see how it's very easy to call the same customer lots of different things, and typically in larger organizations where you might have different segments of the business interacting with other large organizations, it's very easy for the same entity to be represented by multiple different descriptions, and so you gotta come up with a mechanism for normalizing those values to all mean sort of the same thing. And then typically date fields can be a bit of a train wreck as well. So there's a lot of work in dealing with that. And then the other typical things that'll happen is our data might be it might be a date or it might be a number, but it's stored as a text value, and so we have to transform it into the data type that it actually is. And we'll see some of that when we dig into our Twitter data here and do our little mini data warehouse. That all of the data that comes out of our API is represented as text, but we know that we have to change it to a different data type so that we can, if we're dealing with dates especially, do things like date math and all that type of thing. Then the other thing we might be doing is, as part of transformation process is either ranging data. So, salary is a great example of ranging. We might have a salary range in our organization from $30,000 to $100,000, right? Or we might, have sales for customers ranging from, $50,000 to $200,000, and typically these type of values will have lots and lots of unique values, right? So I might make $35,000. You might make $36,000. The guy next to you makes $36,500. Jim down the hall makes $38,000. Another guy makes $50,000. All these individual values don't necessarily have a lot of value, and we're more interested in a range. So we might be interested in employees that make between $30,000 and $40,000 and $40,000 and $50,000 and so on. And then and same for customers, we may be more interested in seeing customers that between $50,000 and $75,000 in revenue, and $75,000 and $100,000, because those ranges have a lot more value than the distinct actual amounts when it comes to data mining. So, and then the other thing is coding values. So if I have if I have male and female in my database, I'm going to need to code that to a 0 or a 1 to represent the two different genders. Same with true false values, or or any other value that's sort of distinct that we need to code into a numerical. And then the other thing we'll want to look for here as a part of the data prep stage is you're going to look for outliers. I've got you know, 5,000 transactions and 4,500, you know, 4,999 of them are between $50 and $100, and one transaction is $300,000, right? So that can greatly skew the results of, you know, data mining. So we need to identify those, one, see if they're valid, and two, decide if we want to include them as a part of our analysis. And then, you know, this is where we really start digging into kind of exploratory analysis. We're beginning to look at the shape and characteristics of our data to make sure that, you know, particularly with outliers, that we've identified those and cleaned out any that don't need to be included. And we begin to, you know, look at the mean and mode of our data and start doing some basic visualizations on it, so we can begin to understand what our data looks like and start to form some hypotheses that you know, we're ultimately going to be testing with our process. And here we're really in a technical domain, if you will, or semi-technical domain here, and you know, depending on the tool set that you're using, is going to depend on, you know, the folks that are going to be involved here. But you're still, you know, probably working with your IT and analytic teams separately. And then, you know, after this, we're really going to be moving into kind of the pure domain and the analytic team. The other thing that goes on here is we may have a bit of a feedback loop going on where we're asking our data warehousing folks to do some of this transformation and filtering and aggregating for us, so that we don't ultimately have to do it in our analytic tool set. So then, you know, you move into the modeling part, and if we kind of scroll back here, look at our diagram, you know, we're moving around the circle here. Modeling is when we're really getting into using our data mining techniques. So one of the things I say is not to be confused with data warehouse modeling here, because, you know, I come from the data warehousing world, and you know, modeling can definitely mean different things to different people. But here we're really talking about the application of data mining techniques. And one thing to understand about data mining is, you know, we're really trying to build models that will, you know, either kind of describe our data or predict what's going to happen in the future. But all of these models are going to be imperfect by design or by default, right? So there's kind of a perception that you know, that, oh, we're going to use data mining or advanced analytics or data science to be able to predict what's going to happen with kind of 100% accuracy, and that's not how it works, right? What we really end up doing is we try to get, you know, we try to be highly confident about things, but, you know, the confidence level that we apply will depend somewhat on the problem, right? So if we are, you know, what we'll see even with the insurance fraud case that we work on in Chapter 5 is, you know, we're not able to predict fraud with 100% accuracy, but we can predict it with 70 or 80% accuracy. That gives us, you know, the potential for a great business value, right? If we have a group of insurance claims and we can, you know, predict, you know, 8 out of 10 fraud cases, you know, that's huge, right? And we'll miss a couple, but that's a lot better than zero. So, you know, that's why this comment is here, and it's important to understand about the techniques that we're applying. Is this is not an exact science, right? It's a bit of an art form, and the reason it's iterative is we're often going through and constantly trying to improve upon the models that we create, based on either more information or continuing to kind of iterate through them. And so really we have two classes of techniques where we're either describing what happened in the past or trying to predict what will happen in the future. And we'll talk more about the kind of categories of techniques, and there's techniques that really kind of cross the lines on both of these, but this is kind of the domain of your analytic team, and this in today's world, might the analytic team and the IT team might be the same folks, or they might be working together, all the way through this, or you may have really technically capable business people that are filling this role, or you may have traditional data scientists, but ultimately you've got folks that are responsible for for applying data mining techniques to the data and getting those models to as accurate as possible, and then bringing that information back to the business users. The last couple steps here is the evaluation, where we're really determining the business value from the data mining results. So the purpose of data mining in all cases is that we are solving a business problem, which generally means we're either reducing costs or increasing revenue, right? Those are the two things that we do in the world. Now maybe the definition of that gets a little broader depending on the type of organization, but generally, for-profit businesses are trying to either make less or make more or spend less, to increase revenue. So ultimately, when we analyze or we evaluate the results of our data mining project, we're saying, okay, are we achieving the business objectives we set out to achieve, or have we discovered some other business value that we can derive from our results? Perhaps we didn't get the original objective, but in the process we've discovered something else that could be used. And then we've got to figure out how we're going to visualize those results so that they can be explained back to the end user. So one of the great things about R that we're going to explore, and one of the reasons people like it so much, is although I showed you what looked very codey there with R Studio, R is also extremely powerful visualization platform as well, and we'll see how we can use R to create visualizations, graphs that can really help us to show the results of the data mining techniques that we've applied to our data. And there are a number of other tool sets that might be available here. We might use tools like R to just produce data that we feed back into a business intelligence system, or some other reporting system that we use to visualize our results. But typically, R and R Studio can be used to produce all sorts of documents. But ultimately, if we come up with something that can be incorporated into a business process, then we're going to move that process into a different application, which really comes down to the last piece of deployment, right? So deployment might mean a lot of different things. We're going to present our results back to the business users. What did we discover? What has been the results of our data mining study? But we may ultimately implement this into some type of application. So if we have, developed a decision tree that our customer service representatives are going to use, then we might encapsulate that into another application that allows them to kind of, walk that decision tree as a part of their process. Or, we may be developing some type of report that we're going to use that business users will ultimately be seeing. So if we're categorizing customers into different clusters, we may have some sort of report that we develop, and that categorization becomes a part of the data warehousing process at that point, and is maybe exposed through a business intelligence program. And then ultimately, if we're going to continue to use the model that we're using, we have to kind of monitor the problem domain for changes, right? So you're going to build a model off of some amount of available information, and presumably more information in that same area is going to continue to come in, and things are going to change over time. So we have to sort of continuously make sure that the model is still valid, and we may be training our model as time goes by to accommodate the changes that we see over time. And at this point, we're really coming back to our business audience and determining how to use the results of our data mining activities back inside of the business. How are we empowering the business users to make some decision that makes the organization better off? What if we discovered that they didn't know, and how can they use that information to gain some type of competitive advantage? It's ultimately what we're trying to do. Now, there's tons of organizations in the world that have used this type of stuff to their advantage. I brought up AWS, Netflix, or Amazon. Probably everybody at this point in the world has bought stuff from Amazon, and you'll notice that whenever you go on there, they're always suggesting other stuff that you might buy. If you're a Facebook or social media user, you have noticed in the past that, hey, I was doing some searches for Hawaiian vacations, and now, strangely, all my advertising on social media seems to be talking about Hawaiian vacations, and that is a direct result of data mining activities. You may also notice too, if you happen to lean one way politically with the type of news that you consume, a lot of the news that you get fed to you through Google and whatnot will kind of lean that way with you as they profile you over time. And so there is all sorts of websites, especially people like Google and Amazon and Facebook and Twitter, are constantly using data mining where they're both using your demographic data, but also your online behavior, and really any information that they can figure out about you to try and tailor advertising towards you, because they sell that advertising, and the more targeted it can be, the better, right? And so if you've ever bought Twitter ads or Facebook ads, you might be completely amazed at just how specific you can be about the people you target with your ads. And if you engage those organizations in helping to try and target your products toward certain segments, they've got all sorts of information that can help other organizations figure out who they should be aiming their products at, based on really the decades of data mining that they've been doing at this point. All right, so that's the CRISP DM is really the gist of what we can glean from the second chapter of the book. They talk a little bit about misclassification costs in there as well, and that is another kind of very relevant piece of evaluation that comes into the process of data mining. So understanding that you are going to misclassify certain groups, and if we're talking about insurance, right? If we're certain that we're going to misclassify certain fraudulent cases and certain as not fraudulent, and certain valid claims as fraudulent, we have to consider what the cost of that misclassification is going to be. And I think what they use in the book is they're talking about whether or not the credit card customers are solvent or insolvent, and the costs that would be associated with misclassification, and then ultimately trying to tune our model to optimize that cost, right? So if we're wrong about whether a customer is insolvent, or we're wrong about whether a customer is solvent, what are the costs associated with being wrong, and then ultimately, how do we lean towards a mix, if you will, in our model that ultimately minimizes the cost of misclassification. And that's a very important point, and something that maybe gets overlooked a lot of the time, about really kind of understanding that when you begin to make decisions based on the information that you're pulling out of your data mining processes, you have to understand that you're by design going to be wrong some of the time, and understanding how that affects your organization is an important thing. All right, so chapter 3 really begins to dig into data warehousing, and then the additional reading that I've given you guys from the Kindle stuff really digs into this. So in the textbook, in our Introduction to Business Data Mining textbook, they talk about a little bit about why data warehousing came about, and what things it's been used for, and really data warehousing in and of itself is a kind of data mining, and a lot of organizations have used data warehousing to great advantage. I think one of the examples that they give is Walmart, right? And they have very famously, from a retail perspective, understood the value of data warehousing much earlier than other organizations did, and really optimized their supply chain and their stores to both minimize the cost of storing goods, but then also minimize the amount of time it takes to get stuff from their warehouses and into their stores, by building a really complex and well-performing data warehouse. And obviously, when you look at the success of Walmart over time, you can see that they've pretty much crushed a lot of organizations like Sears, JCPenney, I'm sure there's a few others that have been kind of run out of business because it just simply were much better at being efficient through really developing a competitive advantage off of using their data warehouse. They're also a organization that is making hay from data mining as well, and they are under a huge amount of pressure from organizations like Amazon, who have been able to apply, you know, both were way out in front of Walmart from an online perspective, but also have gotten the jump on them from you know, a data mining perspective and understanding how to sell to their consumers online. And Walmart in particular is putting a lot of effort into trying to catch up. But okay, what do we need data warehouses for? Why did they come about? Why are they in existence? And this comes down to sort of the differences between OLTP versus data warehouses. So OLTP, online transaction processing systems, right? ERP, kind of same thing. This is this idea that the systems that are designed to collect transactional information, like point of sale systems, like accounting systems, like customer relationship management systems, like HR systems, are optimized to collect information. What does that mean in a data house sense? Data in a database sense means they're really, really good at inserting new information, updating information, or deleting information, right? So they are exceptionally fast at transaction and transaction processing. So if I'm somebody like Walmart again, and I'm, if you think about, you know, a large Walmart on a busy day and all the stuff that is running through the cash registers, and then you think about all the Walmarts across the world and them collecting all of that information, you can imagine we're talking about many, many millions of transactions daily, and the design of those systems naturally kind of requires them to have what's called a highly normalized schema. And so if you've taken any courses on databases and normalization, the point of normalization is to essentially never insert or update the same information twice. So if we have a employee name, for instance, that might be used all across the system, that employee name should only be stored in one place. So if we need to update it, we'd only do it in one place. So these systems are really good at that process, but as a result of that, they're really bad at getting large amounts of information back out of them. So if you're looking for a particular transaction in an OLTP or ERP system, no problem. But if you want to do something like give me sales by customer segment for the last 6 months, these systems are exceptionally poor at doing that because of the fact that they've been optimized for what they're exceptionally good at, which is collecting transactional data. And we'll take a look at why that is here in just a second. So then, what a data warehouse is good at? They're exceptionally good at getting information out, selecting information in an aggregated form across multiple dimensions, right? So what does that mean? If I want to see sales for the past 12 months by customer segment in different states, data warehouses are exceptionally good at rapidly responding to those type of queries. Whereas, you know, depending on the volume of data, a typical OLTP or ERP system might come to its knees in trying to answer that question because of the way that they're put together. And although with the advent of more and more and more, faster and faster and faster computers and bigger servers and more RAM, there's kind of always been this big dream that there could be one database to rule them all. The pure volume of data has managed to outpace, in most cases, that dream of being able to have one system that could do it all. The other thing that kind of interferes too is, typically it's not a great idea to have a huge number of users putting information into a system whilst another large number of users are trying to take information out. It tends to slow systems down a great deal, and even for systems that might be able to handle it, there's a lot of reasons why you don't necessarily want to be doing both of those operations at the same time. So that's why really data warehouses exist, is because it's simply impossible for a lot of ERP systems to produce the kind of reports that folks are looking for. And also it typically requires, from a reporting standpoint, somebody who is really, really knowledgeable in these highly complex schemas that ERP or OLTP systems live on top of. So, a typical PeopleSoft, which is one ERP that I can think of, application will have something like 40,000 tables in it. So you can imagine if you're trying to answer a question and you have to sort through 40,000 tables, what kind of domain expertise it would require to be able to do that, and how that makes it extremely difficult for non-technical people to be able to get reports out of the system. Whereas a data warehouse based on that same system might only have maybe 100 or 150 tables. So you could see that's a massive reduction in the amount of tables that have to be joined together to produce results, and also the complexity of the data model that people have to understand in order to be able to generate reports off of it. So here is a typical example of why transactional systems are so poor at being able to answer aggregate queries or to sum things up across any dimension. So this is, I believe, from PeopleSoft, of one of the big ERPs out there in the world, and this is just the representation of a person inside of the system, right? So you can see that all of the tables, and many tables that aren't included in this diagram, we can see the lines leading off of the page. These are all the tables that would be used to track a person, right? And so typically people are important in HR or sales or this type of thing. And so you can imagine if I have to do a query that needs to get data from all of these different tables, each one of those join operations and each one of those fetch operations and combining of these results across all these different tables takes a great deal of computer resources to achieve. And if we apply this across, say, an organization with 100,000 employees and say something like, give me everybody who makes $50,000 to $75,000 a year who is planning on retiring in the next year, that will just, be a query that will take, hours and possibly days to answer from a schema like this, whereas, it would take only seconds to answer from a data warehousing schema. So if we take a look at what a typical data warehouse schema does, we mentioned that OLTP or ERP systems are highly normalized, so they don't ever store the same information twice. Whereas data warehouses go the opposite direction, and they are often denormalized and trade storing the same information or flattening out the information from these systems in favor of being able to simplify the data models involved and make it a lot quicker to get information out. So typically, these systems are organized in what's called a star schema, which is really just a table, a fact table that has the measures such as revenue surrounded by the or this is a product table here, right? So we have a fact table that has the various transactions related to different products over time associated with customers and shippers and promotions we might have been running, and then there's another table here utilizing about customers and their response to promotions, but they're reusing a lot of these dimensions across these fact tables. And we're gonna dig into this some more, but the basic premise here is these star schemas are a lot simpler to build reporting applications or data mining applications off of, and also are much more responsive than the source systems could ever be from being able to really aggregate data across all of these different attributes. And so we'll take a look at really building a small data warehouse schema and showing the differences between the two systems, and then ultimately how we'll be able to use those inside of our data mining applications. So, from the perspective of the component parts that go into creating an enterprise data warehouse, there's no such thing as a free lunch, right? And so the trade-off for being able to move this information from the source systems and assemble it into a data warehouse that can be used for reporting and data mining systems is, we have the processes that extract the information from the source systems, transform this data into the star schemas that could then ultimately be used for what's called our presentation area, or really the data warehouse schema that can ultimately be used for our BI applications or data mining. And so we'll talk about this some more next week, and then we'll really get into understanding mostly what the front end of this work of this looks like. We're going to do, when they talked about data prep as a part of the process, we're going to do a little bit of this as well, and just kind of understand how this ETL process, or what is really a data preparation process, works in the data warehousing domain, and how that's very similar to what they talk about from a data mining perspective. And a lot of times from a data mining process, going in, if there's a data warehouse in place inside of an organization, going all the way back to the source system can really just be duplicating work. So we want to take advantage of the work that's already been done inside of our data warehouses, so we can get on to actually solving our business problems. So all right, I think that's a good stopping point for this week. I'm going to unmute everybody here and just see if anybody has any questions. If anybody has any questions, does anybody have any questions about the information we've covered this week? If you speak up or throw something out there in the chat window.
My question, I have a question on the SQL developer.
Mm-hmm.
Hello?
Yeah.
I have this software for previous class. Do I need to install it again? Because I have the same account in the Oracle. So
Okay.
I worry about if any conflict because I use the same email on that account. If I use it again, I don't know what will happen.
Yeah.
So
So if you already have SQL Developer installed, the only thing you're going to need to do is just create a new connection. So if you used it for another course or some other application, and here I'll just pull it up here. You know, presumably if you've used it for another course, that course, you know, had you maybe connect to some database on campus. You're just going to create another connection and use it to connect to the cloud database that we've got set up for this class.
Okay.
Yep. If you have any problems with that, feel free to reach out. I'll be happy to help.
Okay, thank you so much.
Okay.
Okay, thank you.
Any other questions? If not, I will obviously post this online. I'll put the slides out there on Blackboard as well, and I'll update the lecture to YouTube in case you need to go back and touch on any part of it. Next week we will be moving into the data warehousing side, and then I think it's the following 2 weeks after that I'll be traveling, so lectures may just have to be recorded. But I'll communicate through Blackboard with you know when I'm traveling and when the week's lectures will be posted online. So one way or another, we'll make sure that we continue to move along. And then if folks need to get up with me, you've got my contact information. We can work that out. All right, I don't see any other questions, so I'm going to call that a wrap for this week. Go ahead and stop